Number 19, they want us to figure out the domain for this. So what is there a restriction on x, or is any x going to work? Well, every x is going to work. It's an absolute value. There's no restriction on that x right there. It could be 10, it could be negative 10, it could be a million, it could be negative million. The answer is all real numbers. So remember, absolute values are v's. Okay, it could be upwards or it could be downwards. In this case, it's upwards because this is positive out front. But either way, it's going to the right forever and to the left forever. Everybody's going to work, so it's all real numbers. Number 20. Here, we're like, hey, what about this guy? Well, this is a little tricky. The top numerator is not going to matter. Anything can go in for x. But the bottom, we have two things we must consider. A square root. Well, with a square root, we would say, hey, that 2x minus 8 piece has to stay positive. It has to be bigger than or equal to 0. Now, why didn't I put or equal to? Because it's in the denominator, so it can't equal 0. That was the other restriction there, because it couldn't come out to be a 0, because you can't put things in groups of nothing. You can't divide by 0. So now, let's just solve this. We add 8 to both sides. We realize, hey, 2x has to stay bigger than 8. Divide by 2, x must be bigger than 4. So number 20, the domain is all real numbers where x is greater than 4. If we put that in other notation, we would say, hey, it's bigger than 4. So if you think of it that way, here's 4. It doesn't include it, so circle, and it goes off to positive infinity for always. So starts at 4, goes to infinity. Does not include 4. Infinity can never be included. So there's that. Number 21. Here, up, absolute value again. So we know it's all real numbers again. Okay? Any x can be plugged in there. And if we want, we can say, hey, negative infinity to positive infinity. In other words, all real numbers.